Good morning everyone, I am Andrea, and in this video we're going to learn how to generate heat maps with Seaborn. And Seaborn is a Python data visualization library which is based mainly on Matplotlib. It basically provides very informative and attractive solutions for graphical representations, and it's very useful especially for data science or infographical applications in which we are basically dealing with large data sets which are often difficult to be represented and to be described. So if you have very large and complex data sets and you want to achieve a very successful and meaningful representation and description of the results, well, you should just stick with Seaborn because it provides very intriguing and versatile solutions. So you can check the documentation. It has a very wide variety of functions and tools. As I said to you, we are going to focus on the creation of heat maps. Heat maps are specific plots which basically consists of the combination of values, numerical values, and colors, a color scheme to represent multi-dimensional datasets. More specifically, in this paper, in this video, just to give you an example of how to create and to use a heat map, we're going to plot the total number of cases of the COVID-19 pandemics recorded for each day in different American countries, different countries of the USA. So basically we can start, and I have already initialized my script. I'm going to start by importing some useful libraries that we will use throughout this video. So I will just import my NumPy as NumPy. We will also use quite a lot actually pandas as PD. Okay, then since we are going to generate some plots, I'll import matplot lib pyplot as plt, and then last but not least, the focus of the video, which is Seaborn, the Seaborn library. We're not interested, well, we can import all the library actually as, let's say, SNS. Perfect. These are the libraries needed for this video. So the first thing that we have to do is to import in some way our original file in which all the data regarding the COVID pandemic are stored. So I will just add a comment here, let's say URL of the CSV file, and I will basically store the URL in a variable called URL, and this should be the place in which I stored the file. You will find the file attached to the blog article. So the next thing to do is to basically import this file as which is a CSV file as we want to import it into a pandas data frame, which will allow us to deal with the file with its content more easily. So for doing this, I will initialize the data frame by exploiting the pandas function read CSV. So let me just write it. read CSV. As the input, the first one is the path of the file, which is URL. Then I have to specify the separator that is used in the file. I mean, this is optional, but I know that I need to specify it. Now let me just finish typing and I will show you how the file is made. So this is the file. Basically, we can just, this is a CSV file, that the CSV file that we are going to process. As you can see, there's a header, and the different elements of the header are separated by a semicolon, and also the different values of each column are separated by a semicolon. And then another tricky thing is that if we go down with the, and we find basically larger numbers, we can see, let's see if I can find them. Yeah, here the thousands are denoted with a comma, so we need to specify also this thing. Basically, as you can see, there are different categories, like the submission date, the state. This will be one of the key elements for our heat map, the total cases, another key element of our heat map, and then a bunch of other things like confirmed cases, probable cases, and so on. We are just interested in these two, the state and the total cases. As you can see, for each day we have the different data that regards this particular state. I guess that CO stands for Colorado, for example. And then there is, I can see, I saw before California, and so on. So first we have all the data from Colorado. Here we have for these dates the data for Florida, and so on, in this way. So to do that, as I told you, the separator between the different values is a semicolon, while the thousands are denoted by the comma. So that's it. In this way, the read CSV function will convert this file, which is present on this URL, into a pandas data frame that we call df. Okay. Now we have just obtained our data frame. We can just have a look at it by printing df head to just sit at the beginning, and as you can see, let's see if it goes. What's wrong? Oh yeah, sorry, thousands. Here it is. These are some of the columns and some of the rows, the initial rows of our data frame. Perfect. So the next thing to do is to extract from this data frame just the values that we are actually interested in, which, as I told you, are the states and the total number of cases for each state recorded on each day. So we can just type a comment in order to define what we are doing. So we are just defining the arrays containing the states. Yeah, let's begin with the states. So let's define the array containing the states present in the study. Perfect. So as you saw, basically the column in the original file, there are a bunch of rows referred to the same state, which falls under the column of the header called state, So basically we have to extract all the values, all the state, and then we will have to get rid of the duplicates. To do that, we just initialize an array, an numpy array called states, and what we will do is that we will so a numpy array, and what are the values that we want to store in this array? They are the values contained in under the column of the either state. So we call this by referring to our data frame, and the header of that column was called state. And then, as I told you, we want to get rid of the duplicates. So we use this method, which is called drop duplicates. That's it. Now, since there are like, I think, if I remember correctly, like 60 different states, since our space for plotting the heat map is limited, we will just focus on the first, let's say, 40 states. But in the end, we will see that we can just generalize this restriction and obtain similar results. It's just a graphical thing for this example. So now basically we have just created an array called states that contain all the names of the different states of the first, in this case, of the first 40 states present in the study. We can just check it. Let's see what happens. Here they are, different, there are no duplicates, and they are the first 40. Perfect. Now we have to proceed further, and we have to now to extract the information regarding the total cases for each day, recorded at each day for each state. So let's see, let's make another comment. And so we have to we are going to extracting the total cases recorded at each day in each state. Perfect. So to do this, we will basically generate two nested for loops, which will allow us iterating through the two different arrays. So the first thing that I have to, well, we can proceed with this. So the first for loop will allow us to iterate through the state array. So for state and states, what we have to do, we have to call another for loops now, which will iterate through the data of recorded at each day for that particular state. And so it's like, for example, for I in range in range, and we can see the length of the data frame column that contains the state, the state, sorry. Okay, because as we saw here, we are just basically, so for example, the first iteration will be for the state and state, so we take the first state, which is Colorado, for example, and we just saying that for the whole length of this column, we just now have to pick the total cases referred to Colorado. So to do that, we have now to write an if statement. So if, for example, df dot state, and which element of the f dot state, the one which with an index I, which is the inner for loop, if this element is equal to state, which is the name of the state that we are iterating through, what we have to do is to append that value, the value of the total cases, to a list, for example. So we have to initialize an empty list before this for loop. We will call it dot cases. Perfect. So as I told you, we have dot cases dot append, and we have to append df dot this time we're interested in the elements stored in the column dot cases. Perfect. And in the element with index I again. So basically, looking at the original file, what we're doing is to what we're doing is that we are entering this state column. So we choose the first state by iterating the first for loop, and like here we start with Colorado, and then we basically check each value of the dot cases column, and we check whether the state value for this index, for this row, is equal to Colorado, and if it is, we store the value of dot cases. We append the value of dot cases in our dot cases list, and then the next iteration will basically go with the second row. We check whether the relative state name, state value of the second row is Colorado again, and if it is, we store the dot cases value of the second row into the dot cases list. And we do this until basically we end up by finishing all the values that are related to Colorado. Let's see if I find that. Yeah, here. So this row, the state value will not be equal to Colorado anymore, because it will be equal to Florida, and so we exit we do not enter the if statement, so we end up the for loop with these values. And the next thing that we want to do is, when we go out from this for loop, we basically end up with a dot cases list that contains all the the number of total cases of COVID-19 recorded at each day. And now we want to basically store to append this array to this list, to another list that will contain all the values for all the states that we are going to probe, let's say. And so for doing that, we basically generate another list here when we go out from the inner for loop, which we call overall cases, let's say, and we basically append to this list the dot cases list that we've just created in the previous for loop. Also in this case, since we are generating a heat map with a finite size regarding the window in which it will be plotted, I personally choose to limit the data to the first 30, let's say, values. So the first 30 days of measurement. And then of course I have also to define this empty list, which will then become a list of lists, a list containing other lists, and I have to do it here before the first for loop. So overall cases equal to empty list. Okay, perfect. So now we're basically done with the creation of the two arrays that are really important for the generation of the heat map. The next thing that we want to do is to create another data frame in which to store these two arrays, since we will see later on, the Seaborn heatmap function accepts as inputs pandas data frames, or at least pandas data frame are a very easy and suitable way for giving as input the values for the generation of the heat map. So to generate the data frame, I will call this, let's say, generate a new data frame, and well, I will call it data, since it will contain the data that I'm interested into, and it's like pandas data frame. Okay, and the content of this of this data frame, as I said, is the content of this general list here that contains all the lists referred to all the different states. And so I will just type overall cases. Now if we take a look at this data frame, we can see here, let's see, just a moment, it's probably taking too long. Okay, here it is. So these 30 are the days, while these 40 are the states. It has it iterated twice. So each row represents a state, and each column represents a day of recording. Since we want to have basically the name of the states in one of these two indexes, whether in the header or in the index of the rows, I personally prefer to have the name of the states as a header, because I think it's simpler to input them in this way. So I just transpose this data frame by adding .t, and as you can see now, the data frame will be transposed. So we will have the 40 columns, which represents the 40 states here as a header, so as the columns, and the 30 rows representing the 30 days that we define here as rows here, as you can see. Yep, that's right, perfect. Now, as I told you, I want to replace this header with the names of the states. As you may remember, the name of the states were stored in this states array, so the only thing that I have to do is to write data.columns equal to states, and this will initialize my in the correct way my header. We can just make another check of our data frame to see how it looks like after this last edit. Let's see. Here it is. Oh yeah, perfect. As the header, we now have for each column the name of one state. So it's perfect. We're nearly done. We now have to plot our data and to generate our data frame. So yeah, some just basic matplotlib command like figure to generate the figure in which we plot the heat map, the axis, subplots. Perfect. Subplots. Okay. And now the heat map. So as I told you, to generate the heat map, we use Seaborn, which we previously imported as SNS dot. The function is called heatmap, and we can just see the documentation to see what it looks like. Here it is. Heatmap. The only mandatory input is the data, which can be a 2D dataset or a pandas data frame, and if a pandas data frame is provided, as you can see, the index and column formation will be used to label the columns and the rows of the heatmap, which is perfect because our columns represent the day numbers in which the data have been recorded, while the column represents the number, the header of the column. Columns represent the names of the different states. So this is why I wanted to create another data frame and to input directly a pandas data frame into this function, because it was more convenient for our purposes. And then there are a lot of different other options. For this reason, I said previously that Seaborn is a really convenient library to obtain really fancy and attractive graphical representation of your data. We will not go through all these options, but only through some of them. So here we are, data. Then I'll just type, for example, we can type the line width. I will place it equal to 0. Basically, line width is the width of the lines that are separated each cells of the data frame. We can choose its width, and we can also choose the color. The default one is white, but we can also choose the color of the line separating each of our cell. I will just type it to 0, and then maybe I could just change them later to show you what's the difference is like. Another option is to choose the color map by typing CMap, and one of my favorite is the Viridis. But also the default one is really cool, I think. I'll also specify this option, X tick labels. Basically, if you set it to auto, it basically distribute the labels along the x-axis in order not to crowd them and to make them as more visible as possible and as more clear as possible. But I will make it equals to true, which means that basically it will plot all the labels that are referred to the x-axis, because I want that all the names of the states will be visible in the heat map. And then let's see whether there is something else. Oh yeah, we can go with annote equals to, let's start with false, and then I'll just make it equals to true. Then I'll just have to, this I will just change it later to show you how it works. I will just type x dot set x label. Yep, and we'll make it on the x-axis. We'll have the names of the states, and on the y-axis we have the number of the day. So it's like day number, which is the number of the days in which are recorded the relative tot cases data. And then just to finish, we have to add finally plt.show. So if we did all correctly, let's see how it looks like. Let's see. This might take a while. Okay, here it is. So on the x-axis we have the states. On the y-axis we have the day number, the number of the days of recording, and these are different cells. And this is the color bar that represents the number to which each cell is referred to, the total case, the number of total cases for each cell. Of course, there is this homogeneous color because we decided to plot only the days from the first one, from day 0 to day 30. So the first days presented very low basically 0 total cases, but we will see later. I will try to put some other numbers to show you that the results will change a little bit. As I told you, if we zoom in we can see more clearly. Let's try to do this here. Yeah, these are the cells. These are 2 cells. You cannot see the division because we basically put the line width equal to 0. So I will just make it again. I will just take it equal to, let's say, 0.5 to see what it looks like if we get a separation between the different cells, the neighboring cells. Let's wait a while. Here it is. Yeah, now we can see the individual cells because they are separated by the white border, the white lines. Another cool things that we may do now is to change annotate equals to true, and now we will have the value of each cell will be annotated in the center of the cells. So we may see the values of the total case of each cells displayed in the heatmap directly. Let's see. It will be probably full of zeros because again it's referred to the first days of measurement. Here it is. Yep. Each cell contains the numerical value of the tot cases to which is referred. Perfect. Yeah, let's try to I will just try to let's try to obtain the heatmap for all the days of measurements, which should be more than 250. If I remember correctly, there are 286, I think. For this, I might change again annotation to false because the numbers will be pretty high, and so there will be not enough space to display them in each cell. I can try to keep the line width equal to 0.5. Let's try to a little bit smaller, like 0.25, and then should be all the same. And I could just, yeah, let's keep with the first 4 states. It's just to see how the graphical representation changes. Now we should see different colors. Now it will be a little bit longer, the process. Here it is. Oh, they're definitely too much, and so I have to disable the line width. I'll put it back to 0. Let's see how it works. Perfect. Here it is. You can see that that now we have different colors because we're basically accounting for 200, sorry, and 86. So for the whole days of measurements. And the numbers, as I told you, they are really high because the yellow stands for more than 800,000, which is quite a lot, and we wouldn't fit this number within this small cell. Okay, perfect. What am I forgetting something? Oh yeah. Oh, I just closed the plot. Yeah, I will plot it again because I wanted to show you another important thing, as you may have already noticed. Let's see. Let's wait for the plot. Yep. There is something that doesn't convince me at all, which is the thing that the y-axis begin with 0 at on the upper corner, which usually we're used to have the lower number here at the bottom and then increasing. We're just increasing the days in which the data are measured. So we just want to now try to reverse this array in the whole plot. This is very simple. We can just type like here the command invert y-axis, and we should be done, I think. Let's try to see how it looks like. This should be, I think, the last iteration to show you the plot. Or maybe I can show you, yeah, here it is. The plot, we basically inverted the data and also the y-axis. Now the y-axis, the day number starts with 0 at the bottom and then increases till reaching 286. And also the number, the content of each cell has been flipped to the other values. So perfect. If you want, I can show you other color map. Like, let's see how it looks like the default Seaborn color map. Just because I think it's really cool, and so you don't need basically to change a lot of the color maps, because Seaborn provides very useful and very attractive graphics. Here you see, yeah, it's very nice. I mean, for me, it's quite. It may be even better, I think, than the original ones. But yeah, of course, it's up to you. So I think we're done. This was the all code that we needed to create a heat map. As I told you, there are a lot of other useful options that you can enter when calling the heat map, the line color, or customizing the color bar, or other the Y labels, and so on. It's really a lot of stuff, but you can basically just read the documentation. It's not that difficult. I think that the most tricky part was to understand what type of data to place as input of the heat map, and how to generate the heat map. So I think that we're done. Hope you liked this video, and yeah, see you in the next one. Bye.